Welcome to Kenton's videos. Enjoy the video.
You begin by shaping the inputs so the network can learn efficiently. First, normalize features and encode labels, then split into training, validation, and test sets. Once done, decide on an architecture, how many layers, neurons per layer, and which activation functions to use, because those choices control representational power and gradient flow. Initialize weights sensibly, small random values or he/savior, so early signals aren't lost. Finally, set up minibatches and a simple forward pass to verify shapes and activations. Now you run training, compute predictions, evaluate the loss that measures error, and backpropagate to get gradients for every weight. As you do this, make sure to track gradient magnitudes so they neither vanish nor explode, because that disrupts learning. Use an optimizer like SGD or Atom to convert gradients into parameter updates, adjust the learning rate, and consider learning rate schedules. Also apply regularization techniques, dropout, weight decay, batch normalization, to improve generalization while monitoring validation loss for early. To finish, evaluate model behavior on unseen test data and inspect error patterns so you understand failure modes. Once satisfied, optimize the model for inference. Prune, quantize, or export to a deployment format to meet latency and memory constraints. After deploying, monitor real-world performance and data drift so you can schedule retraining. If things go wrong, check for exploding gradients or overfitting first, reduce learning rate, add regularization, or clip gradients to stabilize training and recover quickly.
Thanks for watching. Consider subscribing if we helped you.